Okay, okay, let us discuss some of the problems from Module 5. First problem, I already solved problem related to isothermal and adiabatic flow in previous video. Now let us discuss about problems related to velocity of sound and velocity of projectile. So first problem, find the sonic velocity for the following fluid. Crude oil of specific gravity 0.8 and bulk modulus 153036 Newton per centimeter square. This you have to remember. Unit of bulk modulus is actually bulk modulus is equal to dP divided by volumetric strain. Volumetric strain has no unit. So unit of bulk modulus is actually unit of pressure. So second case, mercury having bulk modulus of 2648 700 Newton per centimeter square. So now first write down given data. For the first case, for the crude oil, specific gravity equal to 0.8, therefore density equal to, hope you remember, specific gravity equal to density divided by density of standard fluid. Standard fluid is taken as water here. So in order to get density equal to density of the fluid equal to specific gravity into density of standard fluid. So that is equal to rho equal to 0.8 into 1000, that is equal to 800 kg per meter cube. Now bulk modulus K equal to 153036 Newton per centimeter square. Unit of pressure is actually standard unit, SI unit is Newton per meter square or Pascal. So convert from Newton per centimeter square to Newton per meter square. Hope you know how to convert from Newton per centimeter square to Newton per meter square just by multiplying 10 to the power 4. So next for the velocity, for the sonic velocity or whatever the velocity, we have expression for C as C equal to square root of dP by d rho, that is equal to K by rho. Because K value and rho value is given in problem, so I have to calculate the velocity. So square root of K by rho, just substitute K value as 153036 into 10 to the power 4, rho as 800, and calculate the value of C. C equal to 1383.09 meter per second. Now for the second case, for mercury, specific gravity equal to 13.6. So similar to a previous problem, you can calculate density of mercury by just multiplying specific gravity by density of standard fluid, that is water, 13.6 into 1000 kg per meter cube. Bulk modulus is given in problem. Convert from Newton per centimeter square to Newton per meter square, just multiplying by 10 to the power 4. So sonic velocity C equal to K, square root of K by rho, that is equal to square root of 2648 700 into 10 to the power 4 divided by 13,600, that gives value of 1395.55 meter per second. Here you guys are supposed to calculate as the velocity C. You have to remember two expressions. One is C equal to square root of K by rho, and other one is C equal to square root of gamma RT for adiabatic flow, and C equal to square root of RT for isothermal flow. Three equations you are supposed to remember here. If you remember those three expressions, you can solve n number of problems. So next, let's go for second problem. Find the speed of sound wave in air at sea level where the pressure and temperature are 10.1043 Newton per centimeter square absolute. So no need of converting to absolute again by adding atmospheric. It is already given in total pressure or absolute pressure, and 15 degrees centigrade respectively. Temperature is given as 15 degrees centigrade. Take R equal to, this is a gas constant, equal to 287 joule per kg degree Kelvin, and K, instead of K I already told in derivation also, you can take this K is actually ratio of specific heat, you can take gamma equal to 1.4. So solution given, pressure P you just write down the given things. Pressure equal to P equal to 10.1043 Newton per centimeter square. Newton per centimeter square has to be converted to Newton per meter square just by multiplying 10 to the power 4. So 10.1043 into 10 to the power 4 Newton per meter square. Temperature, this is degree centigrade, we are going to use small letter T. T equal to 15 degrees centigrade. So in order to get temperature in Kelvin, you have to add 273 to 15. To capital T equal to 273 plus 15, that is equal to 288 Kelvin. So R value, anyhow it is given directly, R equal to 287 joule per kg degree Kelvin, and K or gamma equal to 1.4. So for adiabatic process, I already told about this thing formula. C equal to square root of KRT. KRT. So KRT is or gamma RT. Gamma value is 1.4 into 287. R is 287 into 288. Just take the square root. So you are going to get 340.17 meter per second. So hope you guys can ask why we are going to consider here adiabatic flow only. Adiabatic flow, that is C equal to K square root of KRT. Why can't we consider isothermal? I already told about this thing in note. If they are not going to mention about any process like isothermal or adiabatic, it should be considered as adiabatic flow. Otherwise, they are going to specify like calculate the velocity using isothermal process for an isothermal process. So here, nothing is mentioned. So consider it as an adiabatic flow. Next problem. Calculate the Mach number at a point on a jet profile aircraft which is flying at 1100 km per hour at a sea level where air temperature is 20 degrees centigrade. Take K or gamma equal to 1.4 and R equal to 287 joule per kg degree Kelvin. So given speed of aircraft, so that is kilometer per hour, speed should be always in meter per second, that is the standard unit, SI unit. So you have to convert from kilometer per hour to meter per second. How to convert? V is given as 1100 kilometer per hour. Kilometer means 10 to the power 3 meter or 1000 meter. So we 1100 into 10 to the power 3 meter. So 1 hour is 60 into 60, that's 1 hour is 3600 second. So 1100 into 1000 divided by 60 into 60. So that gives the velocity in meter per second, that is equal to 305.55 meter per second. Now temperature T equal to 20 degrees centigrade, is a small letter degree centigrade. So get temperature in degree Kelvin. So T equal to 273 plus 20, that is equal to 298.93 Kelvin. K or gamma equal to 1.4, R equal to 287 joule per kg Kelvin. So for the equation again here nothing is mentioned about the process isothermal or adiabatic. Let me consider it as adiabatic only. So C equal to square root of gamma RT or KRT. So that is equal to square root of 1.4 into 287 into 293. That is equal to 343.11 meter per second. So they again told to calculate the Mach number. So Mach number is given by V by C. V value we have, that is 305.55, and C value whatever we have obtained now, that is 343.11. So M equal to V by C, that is equal to 305.55 divided by 343.11, that is equal to 0.89. Very simple problem for 10 marks. So next problem, an aeroplane is flying at a height of 15 km where the temperature is minus 50 degrees centigrade. The speed of the plane is corresponding to Mach number 2.0. Assuming K equal to 1.4 and gamma R equal to 287 joule per kg Kelvin, find the speed of the plane. So K or gamma value is given as 1.4. It is always 1.4. So for adiabatic process, if it is not given in the problem, means you have to just assume K or gamma equal to 1.4. Now solution, first let me start with the given things. So height of the plane, that is Z, that is equal to 15 km. This is extra data, we are not going to use anywhere. Temperature small letter T equal to minus 50 degrees centigrade. Don't forget to convert from degrees centigrade to Kelvin here. So capital T equal to minus 50 plus 273, that is equal to 223 degree Kelvin. So Mach number, that is M equal to 2.0, that is the supersonic case is given greater than 1. Gamma or K equal to 1.4, R equal to 287 joule per kg Kelvin. So again using adiabatic flow velocity formula, C equal to square root of K RT or gamma RT. So that is equal to 1.4 into 287 into 223 square root. So that gives 299.33 meter per second. Now they told to calculate the Mach number. So Mach number, so told to calculate the velocity. So M equal to V by C. Now you know value of M as 2 and C as 299.33. So it is very easy to get value of V, that just by multiplying Mach number by velocity of sound wave. So M into C, that is equal to V. So V equal to 2.0 into 299.33, that gives 598.66 meter per second. So they told to get the speed in meter per second, or you can convert to kilometer per second. In order to convert from kilometer per second, kilometer to kilometer R to meter per second, you multiply 1000 divided by 3600. This is exactly reverse. Multiply by 3600 divided by 1000 here. So 598.66 into 3600 divided by 1000. So that is equal to 2155.17 kilometer per hour. So otherwise you can just keep 598.66 meter per second, because they didn't ask in kilometer per hour here. So next problem, a projectile is traveling in air having a pressure and temperature as 8.829 Newton per centimeter square and minus 2 degrees centigrade. If the Mach angle is 40 degree, find the velocity of the projectile. Take k or gamma equal to 1.4, r equal to 287 joule per kg Kelvin. So given, write on the given content, pressure of the air P equal to 8.829 Newton per centimeter square. Convert from Newton per centimeter square to Newton per meter square. So 8.829 into 10 to the power 4 Newton per meter square. Temperature of the air, that is in degrees centigrade, T equal to minus 2 degrees centigrade. So capital T, that is in Kelvin, T equal to minus 2 plus 273, that is equal to 271 degree Kelvin. Mach angle alpha, that is Mach angle is represented by alpha, that is given as 40 degree. And k equal to 1.4 or gamma equal to 1.4, r equal to 287 joule per kg Kelvin. So they told to find the velocity of the projectile as capital V. So now we have from Mach angle expression sin alpha equal to C by V, or that is equal to 1 by V. So sin alpha value is given as 40, and that is for sin alpha or sin 40 equal to 0.6427, that is equal to C by V. But you have to get the value of V here. So in order to get V value, you should know the value of C. So C value can be calculated similar to previous problem, that is C equal to square root of K RT or gamma RT. So that is equal to square root of 1.4 into 287 into 271, that gives a value of 29.98 meter per second. Just substitute that value. Sin 40 equal to 0.6427, that is equal to C by V. C value obtained, that is as 330 divided by V. So just multiply the values, or you can simplify the expression. V equal to 330 divided by 0.6427, that gives a value of V equal to 513 meter per second. That is the velocity of the projectile. Very simple problem. To remember one expression, sin alpha, that is a Mach angle, equal to C by V. That is not that is actually equal to 1 by m. If you remember m expression as V by C, then it is very easy to remember expression for sin alpha, that is actually equal to reciprocal of Mach angle. Next, last problem. A projectile travels in an air of pressure 10.1043 Newton per centimeter square at 10 degrees centigrade at a speed of 1500 km per hour. Find the Mach number and Mach angle. Take k equal to 1.4 or gamma equal to 1.4 and r equal to 287 joule per kg Kelvin. Just write down the given things. Pressure is 10.1043 Newton per centimeter square. Convert from Newton per centimeter square to Newton per meter square, just multiplying by 10 to the power 4. Temperature small letter t is given as 10 degrees centigrade. So capital letter T equal to 10 plus 273, that is equal to 283 Kelvin. So speed of the projectile, that's capital V, is given as 1500 km per hour. Kilometer is equal to 10 to the power 3 or 1000 meter. So just multiply 1500 by 1000, and you have to convert from r to second. So r to second can be converted by dividing by 3600. 1500 into 1000 divided by 3600, that is equal to 416.67 meter per second. So for adiabatic process, the velocity of sound is given by C equal to square root of K RT or gamma RT, that is equal to square root of 1.4 into 287 into 283, that is equal to 337.20 meter per second. Now Mach number is given as M equal to V by C. V value you have 416.67, C value you have 337.20. So 416.67 divided by 337.20 equal to 1.235, that is the Mach number. This is greater than 1, that is a supersonic flow. Now Mach angle is obtained from equation sin alpha equal to C by V. I already told about this thing in previous problem, or that is equal to V by C is Mach number. Here we have C by V, that is 1 by m. So sin alpha equal to 1 by m. You have value of m as 1.235. So sin alpha equal to 1 divided by 1.235, that is equal to 0.8097. So in order to get alpha, take sin inverse of 0.80897, that is equal to 54.06 degree. Okay, one more problem is there. Let me discuss. This is the last problem. Find the velocity of bullet fired in a standard air. Is a very important problem. If the Mach angle is 30 degree, take r equal to 287.14 joule per kg Kelvin and k equal to 1.4 for air. Assume temperature as 15 degrees centigrade. So solution, let me start with the given things. Mach angle, that is alpha, is given as 30 degree. R equal to 287.14 joule per kg Kelvin and K or gamma equal to 1.4. Temperature small letter t, that is given as 15 degrees centigrade. Get capital letter T by adding 273. So T equal to 15 plus 273, that is equal to 288 Kelvin. Now velocity of sound is given by C equal to square root of k RT or gamma RT, that is equal to square root of 1.4 into 287.14 into 288, that is equal to 340.25 meter per second. So they told to find the velocity of bullet fire. So sin alpha equal to C by V. Sin alpha value is given, C value we know, so we can calculate the value of V. So sin 30 equal to 340.25, this is the value of C divided by V. So upon rearrangement we get V equal to 340.25 divided by sin 20, that is equal to 680.50 meter per second is the velocity of bullet. So you have to remember here three expressions. One is C equal to square root of k RT for our gamma RT, that is for adiabatic process, and C equal to RT square root of RT, that is for isothermal process, and sin alpha equal to C by V, that is equal to 1 by M, that is the Mach angle, and other thing is Mach number equal to V by C. That if you remember these four expressions, then it is very easy to solve the problem and you can easily get 10 marks. So this is about the problems. Tomorrow's video I am going to discuss about stagnation pressure, stagnation temperature and density and its related problems. That is the end of your fifth module. Okay, thank you.